mode is always less than the directivity of the axial mode, because that is radiating only in one direction. This is radiating in all direction in the horizontal plane. So this will have less directivity as compared to the axial mode. Okay. Next one is slot antenna. Okay, so slat antenna is something similar to dipole antenna, lambda by 2 dipole antenna, but lambda by 2 dipole antenna is simply like a conductor. Okay, lambda by 2 dipole antenna is simply like a conductor. Say for example, if your antenna shape is something like this, like a conductor, that is simply lambda by 2 dipole antenna. Okay, this is simply a conductor. If the length is lambda by 2, then it will act as a lambda by 2 dipole. This is lambda by 2 dipole. Okay, instead of a conductor, okay, instead of conductor of the shape like a cylindrical shape, you can take sheet. Okay, conductor sheet. Okay, if you take a sheet like this, okay, if you take sheet like this, okay, I'm not taking the conductor, please imagine I am taking only sheet. Okay, only simple sheet. Okay, I take simple sheet. Okay, conductor sheet again. Okay, if I take some sheet, and here also length is lambda by 2. Okay, I'm not taking the I'm taking conductor, but this is not of shape cylinder, I'm taking like a sheet. Okay, then this antenna is called as slot antenna. This antenna is called as slot antenna. So then what is complementary slot antenna? What is complementary slot antenna? Already a sheet of conductor is there, big sheet of conductor. Okay, from the sheet of conductor, okay, from the sheet of conductor, I remove this portion, remove this portion. Okay, I have removed this portion from this. The left out portion will form another antenna. Okay, the left out portion will form another antenna. Okay, if I remove this portion, the removed portion is acting as a slot antenna. The remaining portion will act as a complementary slot antenna. Complementary slot antenna. So then what is the impedance of the slot antenna? That is ZS. What is the impedance of the complementary slot antenna? That is ZC. Then ZS and ZC is equal to eta square divided by 4. You know what is eta square? That is what, sir? 120 pi, or what I can say 377 ohm. Okay, then what is the impedance of the slot antenna? Okay, the impedance of the slot is something similar to dipole. So the impedance of the slot antenna is 73 plus j 43 ohm, because if it is only dipole, then definitely you may have only resistance. And again, uh, please make sure that even for lambda by 2 dipole, we are considering only 73, but that also consists of some other reactive impedance also. If you refer standard textbook, that will be available there. Even your lambda by 2 dipole also will consist of some imaginary part. Okay, so now this is the value of impedance value of the slot antenna. Then by means of substitution, you can find out what is the impedance of the complementary slot antenna. That is 363 is J211. Sometimes they are interested only in the magnitude. Then you can put magnitude everywhere. Okay, you can put the magnitude. Then you can calculate the magnitude value. Most probably you'll get question from this. Mostly you will not get. If at all, if you are getting the question, you may get based on this formula. Okay. Next, log periodic antenna. Okay, log periodic. You please note down whenever log comes, some kind of compression is there. When you need compression, when the range is very, very high, you need compression. When the range is very, very high, you need compression. So log means what? Some big number is there. For that you are taking log. That means what? You are going to design a antenna that is going to work for very long range of frequencies. That's why you are going to take log. Okay, log means what? Big. So that means what? Log periodic antenna is a broadband antenna or wideband antenna. That's very, very important. Okay, log periodic antenna means broadband or wideband antenna or wideband antenna. Okay, then what is the structure of the log periodic antenna? It's very simple. Say first I take one conductor like this. I increase the length of the conductor like this, like this, like this. I can keep on going. Okay, so now This is my source. I'm going and taking my source. I'm connecting here and making criss-cross connection like this. Like this, I'm making the connection. Okay. Now, what is this one? This is like a one conductor. I am taking another conductor. The length is I, and again I and I. Then what is the meaning? When you give some frequency, say you are giving some frequency. Say for example, I am giving some frequency. For that frequency, this antenna may be radiating when I give this frequency. Now what will happen? This is my F1. Okay. When I increase my frequency, if I choose frequency that is greater than F1, what will happen? Okay, you are having some frequency. Your frequency is radiated by this antenna. Okay, that means what? For this frequency, you know what is lambda 1. Okay, when you have F1, you know what is lambda 1. That means this length of the antenna is lambda 1 by 2 because you are using off wavelength dipole antenna. That means what? You might have designed this antenna such a way its off wavelength is equal to the wavelength formed by this F1. So when you are operating at frequency F1, that is radiated by this antenna. Then definitely, if you are increasing the frequency, definitely your antenna length will reduce. That means what? If you increase your frequency, instead of this antenna will radiate your power. If you still increase the frequency, this antenna will radiate the power. Or otherwise, if you decrease the frequency, the antenna height will increase. Then this antenna will radiate. Okay, then this antenna will radiate. Then what you understood, you can give any frequency at a particular time, particular antenna is working. Okay, particular antenna is working. By means of this procedure, you are finally increasing the range of operating frequency. You are finally increasing the range of operating frequency. That's why this antenna is called as broadband antenna or wideband antenna. Broadband antenna or wideband antenna. Then what is this design procedure? What is this design procedure? The S is called spacing between the antennas. Okay, S means what? Spacing between the antennas. Okay, then L means length of the antenna. Okay, L means length of the antenna, and R means range of the antenna. From the beginning, how far your antenna, that is R. Okay, range of the antenna. So then this has to follow this procedure always. This value Sn plus 1 divided by S1 is equal to Ln plus 1 divided by Ln. Rn plus 1 divided by Rn is equal to 1 by tau. Okay, tau means tau value could be anything around between 0 to 1. It's like tau means spacing factor. Okay, what is tau? Tau means spacing factor. Okay, spacing factor. Okay, so based on this equation, you have to design your antenna. Okay, you have to design your antenna. Okay, then what is the properties of this antenna? This is operating over large frequencies. This is operating over large frequencies. Then why it's called as log periodic? Why it's called as log periodic? Okay, now in this axis, I am going to mention antenna properties. That properties could be anything. Okay, what is the property means? What's the radiation properties, input impedance, and directivity? Like this, you can mention anything. Now, in this axis, I am going to mention frequency. This is, and again, this is log frequency. You have already designed the antenna. You mark your properties, any one of the properties. Okay, then it follows like this. That means what? Say if you are here some frequency, okay, you are getting some value, say input impedance. If you go here also, you are getting same input impedance. That means what? Your property is getting periodically repeated. Your property is getting periodically repeated. Whatever may be the properties, let it be input impedance or some other properties. Okay, you observe the property nature at one frequency, and another frequency you are observing, you are getting same properties. That's why this is called as log periodic antenna. And also the axis, the bottom axis is in terms of log. You cannot take ordinary frequency, log frequency, because this antenna is working over large range of frequency. That's why the bottom is of the nature of log. So due to this nature, this is called as log periodic antenna, log periodic antenna. So what I'm telling, all properties such as input impedance, radiation properties, and any other properties, and radiation resistance remains periodic. remains periodic with respect to log f, with respect to frequency. That's why this is called as log periodic frequency. So then where we are using log periodic antenna, where we are using log periodic antenna, okay, what is the application of log periodic antenna? One is high frequency communication, okay, high frequency broadband communication, and another one is TV reception. TV reception, because for TV reception we need a broadband antenna, because TV by nature TV itself is a broadband, because you know TV bandwidth is, ordinary bandwidth is, before modulation itself TV bandwidth is 5 megahertz. After modulation it is around 7 megahertz because of vestigial sideband modulation. Okay, without modulation TV signal bandwidth is 5 megahertz. After modulation, that is 7 megahertz due to vestigial sideband, because more than FM, less than 2 FM. After modulation 7 megahertz. That means what? At least your antenna has to, your antenna properties, okay, your antenna has to